optimize, you would apply the same step. So yeah, let us write, okay. So the steps required would be, let's say, analyzing the question, writing the given, and figuring out how to optimize. Okay, so let us and underline those, let's say, numbers, assign letters for those numbers. So we have a box with a square base. You see, so this is a square base. It's not base, because if it is not a square, it would be like a rectangle or whatever shape, and those are not required in your course. Okay, square base has a specific, let's say, start. Okay, all sides are equal. This is the square base. All sides are equal. Now the volume is given, because this is a box. So if I want to just have a little figure, okay, whatever the box looks like, let's say, take it a little up. Okay, so this is the square base. Okay, and we have a volume. So the volume is given to be 54. The unit is indicated to be meter cube. Now we are talking about the material of the box. Okay, so far, no, let's say, no base information is given so far. It's only the volume. Anyhow, let's keep reading. The material, so they shift to something else. The material has to do with, so be careful. When I'm talking about the material, I'm talking about the surface. And this is the one I talk about the surface. It's like the inner part, which has to be with the area. Now the units give you a hint. Some students are confused right here or are lost, so be careful. Meter cube has to do with the volume. Okay, now the meter square has to do with, so the material that they are talking about may be interpreted as a parameter. It's like the sides, the addition of those sides. But since it is in square, they are talking about the inner part. Clear? Okay. So the meter square unit has to do with the area. For that reason, I shift now to the surface area.
Okay.
Because we talked last time, I guess, at one moment, when we have a 3-dimension an area, we say surface area. You are touching the, let's say, the object from apart. Okay, so imagine you have a ball. Okay, we have the volume is the inner space, but when you touch the ball from outer part, so we call it the surface area. Anyhow, the surface area now has to do with the faces of your box. So how many faces do I have? Now we get into the details of the box. So I have a box, I have the base. Now the base is similar to the top. Okay, you see? So, yeah, tell me, what info do you have so far? So this is the base, that is the top. Now, what do you call those standing? What do you call these?
The sides.
Okay, yeah, but I mean, those are standing faces. Those are the faces.
Okay.
Because when you say a side, that is a side only. But I mean a block. So this is a face. Now, how many of those do I have all around? How many faces do I have? How many do I have?
6.
I have 6.
Yeah, 6.
Let's say, okay, front, back, left, right, top, and bottom. Okay, but those standing are only 4. So the base and the top, if you take them off, I still have only 4. Okay, so I have a front and the back, and I have left and the right, and that's it.
Yeah.
Okay, so those was your surface area. I have 4 going around and up, down, so they are 6. But be careful. Yeah, sometimes they say it's open top, so be careful for that trick. Now I have the top right here, but if it is open, I won't include. Okay, so if I want to interpret what's given, the surface area is composed of 6 faces. Okay, now the area is length, width. The base, copy what is given. The material for the box, and that of the top only, it's much more, which is 6. So let us assign, go ahead, assign letters now. Usually, let's say length width. So this is, let's say, an X. This is a y, okay, xy, and the height would be the h, okay? And that's it. All the dimensions are composed of y for the base, and the height would be equal everywhere. So if I want to write the volume in terms of those letters, what do I get? Now I don't have a y, I have an x. So this is what's good. Because it's a square, so I have xx for the base. So I have all those to be x sides. Okay? Okay, and the height I can give it a name as a y, just for simplicity. Is it good?
Yeah.
So I have only x at the base because it's a square. Okay, otherwise it would be xyh. And that is not in your course, by the way. Only on your course you have two letter names, okay? X and a y. Okay, x is the base composed of those sides, and y is the height. So the volume would be x squared times y. Okay, I am done. And the surface area, let us start for the base. Let me write for the base. It is for the top and for the rest of the faces. I'm just explaining rest of faces. I'm just explaining. Okay. Now for the base, it is, what is the cost for the base? It is $2 every meter square. So how many meters square do you have? I don't know, but in letters, I have square of that face. I have x square of this area. So if every meter square is $2, so x square of this would count to 2 times. So this would be 2 times x squared. Do you agree? Is it good? Okay, now for the top, it costs you $6 every meter square. How much on top? It's the same as in the base. So it is again, x squared cost is 6 now. You get it? Okay, so I am just, let's say, doing step by step. The cost of the base is this. The cost of the top is that. Now the rest would compose of the two again, okay? Because the base and the rest are each of the cost $2. It's only the top 6. So the rest would be $2 for every meter square. But how many faces do I have? We said we have 4. So it is a 4. Each is composed of x times y, because this is x and that is a y as an area. Okay, I have 4 of this. Okay, and the cost is how much? Is it $2? So times 2. Any question?
No.
Is it clear? Again, why I'm multiplying those numbers with the letters? Because it is given that this is the cost for every meter square. So if I say $2 for every meter square, how much would be for x square? Imagine that area is like a 10 meter square. So it would be 2 times 20. Okay, but I don't have numbers here. I have missing dimensions. So this is x square. For that reason, I'm multiplying 2 by x square. Okay, that's it. Anyhow, so that this is a traditional question that you may face in an exam. Okay, you want to jump right away to those relations. Anyhow, you want to simplify a little, because I can add up right here. Okay, and 4 times 2. Now this is your what? What do you call this? Surface area. Okay, this is surface area. We can write it as a abbreviation. Now surface area is in is an expression. It is in letters, but with the volume given, the volume is 54 numbers as x square y. Okay, so tell me, what is your next step? What is it about, by the way? I want to find the dimensions that minimize the cost of the box. So I want to find the values of x and y. Now this is step 1. What is step 2? Step 2 is you want to make the relation that has to do with minimize or maximize, okay, in one letter name. So I want to what? I want to minimize the cost. It means I want to minimize the surface area. And the thing that you want to optimize is the thing that you want to derive, that we mentioned last time. But if I want to derive this, it should be in one letter name. So we say make it change it to one letter name, make it in one letter name. It is a must. Okay, now you can choose all in x or all in y. Okay, so let us how can you decide, by the way, because you want to get x in terms of y or y in terms of x, so you jump to this relation which has to do with the, okay, now it's easy to find y not x, because I want to square root right here. Okay, easy to find y. So there's no rule which one you get. Either way, but you should find the simpler letter name.
Okay.
So for me, I want to find y. Y equals 54 over x squared. Replace it in. I would get the surface area to be. So instead of the y, I want to plug in 54 over. That's it. So this is in one letter name. Okay, you can simplify it if you want. For sure, I can multiply 8 times, and I simplify x over x squared. Okay, go ahead. So 8 times 4, I have a 343. Okay, I have 432 divided by x. Okay, I simplified the letters x over x squared. Is it good so far?
Yep.
Okay. Now, this is the surface area. We say this is step 2. Step 3, so we say to minimize the cost. Now, this is the theory, to minimize the cost, because the cost is involved in the surface area. You see, those dollars are involved in. So to minimize the cost, well, there's a little what confusion here. The surface area, yeah. Do I have to give the cost name for this? Is it?
Pardon?
Yeah, this is the cost, not the surface area. The surface area are the dimensions like x squared.
Okay.
But when I put the dollars in, those, this is the cost.
Yeah, ends up being
Right here, yeah, because I shifted from the surface area right to the cost. So the surface area are the 6 faces. It is those in green, yes, okay, but this is the surface area. But I shift right here to the cost when I was talking about the, okay,
money.
every $2, yeah, for 1 meter square, how much would be? So I shifted from surface area to cost at that step. That should be a cost now. Yeah, it makes sense because that I need to minimize or maximize. Okay, so yeah, to make it relevant, it's just the name that you assign anyhow. So this is stands for the cost. This stands for the C. Okay. Now to minimize the cost, it means you derive and you put it equals to 0, because the maximum minimum happens when no rate of change. This is the theory. It's okay. This is the theory. Rate of change of the slope is the derivative. So minimizing, maximizing at a certain relation when it is static. No increase, no decrease. There is nothing at all. So anyhow, for that reason, the theory says you should derive your expression. So it's in one letter name, derive it, and put it to 0. You can find the missing letter. So it's 16x. Now deriving this would be minus 432 over x squared. Any question? Now, if you wonder why that happens, because I can push the x up. Okay, I can write it this way for simplicity or to avoid quotient rule. So I want to do it very fast. So the minus goes to the front, and I get minus 2. I push it down. Any question? Okay. And if you don't want to do it that way, I mean, what I did is like I applied quotient rule fast.
No, I was just about to say that I like how you did it, yeah, with the minus
1. Yeah, I applied quotient rule fast. So what I did is like, if you come on right here, I did u prime v minus v prime u.
Yeah.
This is 0 times, so I won't try it, minus, deriving the x is a 1 times 432 over x squared. Those I don't try, okay? You get it?
Yeah.
Anyhow. So you can get the derivative in many ways. So this is one of the ways. Anyhow, that is 0. Now it is a 0. So let me write, this is a 0. So you want to solve for x, I would isolate one term. So let me push this minus right here. There are many ways even at that step, but this is one. Okay, because it's a 0, I can isolate. And now cross multiply to get x. Again, you can approach it in a different way even, but this is the best. So if I cross multiply, this happens. And then divide to get x. That's it. Cube would be, use calculator, how much do you get? And then cube root of it, okay? That's it. So you can pull 432 over 16, how much do I get? 432, yeah, 432 is 8 times 54 and 54. Anyhow, we can use calculator.
That's 27.
Yeah. Is it a nice number or
No, is it 432 by what? 16?
divide by 16?
Yeah, it's 27, yeah.
Okay, 27. Yeah, it's a nice number. Sometimes you don't get that nice numbers. Okay, 27. And then x would be the cube root of. Okay, so whatever exponent you see, you do the root of. If it is x to the 5, fifth root of. If it is power 2, square root of. Anyhow, that is nice. So you get a 3. Now is reserved, which is in meters. You go up. So you follow the same unit given. If this is in meter, so this is 3 meters for x. Okay, that is designing the base, and that's it. So the question is, what are the dimensions? Okay, that's it. What are the dimensions that minimize the cost? You say x should be this, but how much is? I go up to the volume. Okay, the volume right here. So this is my y, 54 over x squared. I want to get the y, which is the height of the box. And we are done, finish. So how much do we get? So we say replace y equals 54 over x squared, which is 9, and we get 6. So you can write it. Yeah, it is online exam. So maybe you fill in, but this is what you want to conclude. We say that the dimensions, blah, blah, the dimensions, okay? The dimensions for the box to minimize the cost should be, okay, should be 3 by 6, okay, 3 by 6, which is, I mean, 3 for the, so 3 for the base, so it would be 3 by 3 by 6 if you want, okay? And you can check if it is right, by the way, because the volume should count to 54, so it is right because it's 9 times 6, which is 54 meter cube. Any question? So yeah, in some of the online, you wanna present your answer. So this is, let's say, length, height. They may ask you what is the length and the width. So it's because it's a square base, so length equals width. L equal W equal 3. Make sense?
Yeah.
So these are the dimensions, I mean, in brief. And sometimes they say, yeah, put the numbers of your dimensions. So you say 3, 3, 6. It depends how you want to present your answer. Yep, go ahead. Yeah, a little drawing would be helpful on just, I mean, to figure out the dimensions, not to forget. Okay, so we are talking about a cylinder. We have the radius, we have the height. Okay, it's open top. Okay, you see those to be taken into consideration. Go ahead. A little figure is helpful. So let us say the cylinder is like a can. Okay. So this is the radius. Up and down at the base are the same. So this is R right here. This is R again. And that is my height. And that's it. Perfect. Okay. So what is given so far in a can? So this is the base. I can color it this way. Okay. R is there. Okay. So let us write what is given. The volume of the cylinder, right away, the volume of the cylinder is given to be in unit centimeter cube. Okay, right away, what do you know about volume in? So we continue. Okay, so the volume of the cylinder is given, but we know that the volume has to do with the base times height. So the base is the circle, which is pi r squared that we have taken, and the height. So this is the volume, okay? Now you notice that this is in terms of 2-letter names, okay? Anyhow, what is it that I wanna minimize or maximize? So they are talking about being the smallest, okay? We said we don't derive what is given. We derive what is it to minimize or maximize, okay? So it has the smallest area. They give you something and they talk about another thing. That makes sense because otherwise we won't be able to solve.
Mhm.
Okay.
Yeah.
So I should write a relation in surface area now. We are talking about a cylinder. So go ahead. The surface area of the cylinder is how much? So again, SA for the cylinder. How much would be the surface area? It's the touching surface of the can. If you hold the bottle, let's say, uh, can bottle or whatever, that makes a cylinder face. So when you touch the material is the surface area. And you know, it is the round. It's the round. The round is 2 pi r.
Mhm.
Okay, all along the way. So it is h. This is the way I. Okay, question? Any question? So this is the formula for the volume. That is for the surface area. Okay. Now that I should derive the surface area because I want to find the smallest possible. I cannot derive unless it is in one letter name. So what
Exactly.
you do is you go back, you go up, and replace one of the letters. Which one easy to find? Now pi is not a letter, okay? Pi is a constant, 3.14. So we are talking about R or H. Tell me, which one is easier to find, H or R?
H.
H, yeah, because R, if I can find, but I would do the square root later on. So I want to avoid working in radicals. For that reason, H is easy to find. Go ahead with, so yeah, I would write H equals, so I want to say H equals, divide by all letters beside or all quantity beside, which is pi r squared. So it would be 1000 divided by pi r squared. Finish. Good. Okay, replace it in. So the surface area would be in one letter, which is r, 2 pi r times this quantity. Okay, that's it. Now, simplification is a must. Okay, simplify the expression. What do you get? I would get 2 times, you get 2000 pi divided by r. Okay,
Mhm.
any question?
Mhm.
Okay, well, the surface area, by the way, because it's an open top, there's something I missed right here. There's something I missed right here. What is it? Can you figure out? There's something missing because I don't see the formula incomplete. It's not complete. So the surface area is not proper, by the way. It's not correct.
Yeah.
Surface area is missing one thing. What is it? Well, what I did, the surface area of the cylinder, what I did is like I computed the what it's like the surface of the round bottle, okay, but I didn't count the base. The
Okay.
surface area of the base is pi r squared. I didn't add it up. Now, if the top is included, I have 2 pi r squared, but the top is not included. You agree? Open top. Any question? Is it good?
Good. Yeah.
You see, you didn't tell me like I passed all this, but you didn't tell me about the formula. Okay, the formula was not right.
Okay.
Okay, but anyhow, if you miss any, you should be able to tell if it is right or wrong. Okay, you can go back and
Mhm.
fix it. Anyhow, this is my surface area. So I was talking about the round, but I missed the base.
Mhm.
Any questions so far?
Mhm.
Okay, so the surface area would be this. It's correct. 2 pi r, I replace n plus pi r squared. This is my complete formula for the surface area. Now I want to simplify it before I derive. So simplify my surface area. So I will get surface area equals, again, 2 times, I have a pi, r over r squared is on r, okay, plus pi r squared. Good? Now, to optimize your surface area, it means either maximize, minimize. So I want to derive. I would say derive SA, and put it to 0. Okay, let us derive it. So 2000 pi is a constant. It's like something number over x. R is my letter name. R
Mhm.
is the thing that I want to derive. Okay, pi is a constant. Again, so deriving 1 over x, by the way, is minus 1 over x squared.
Mhm. Quick question.
Yes.
Why is it that the pi disappeared on the denominator over with 2000?
Oh, there's a pi r squared. Yeah, I should take it off then. Yeah, pi.
Oh, yeah.
Yeah, I didn't notice.
Yeah.
So by the way, it is Yeah, there's a pi here, so pi cancels. Yeah,
Yeah.
take it off. Pi cancels. I want to take it off from this guy.
There,
Okay, good. So deriving 1 over x again, deriving 1 over x is minus 1 over x squared. So let me put those in different colors. Not to be derive. So derive and put it to 0. Deriving as a, we get 2000 over r squared and minus. If you have any question, you ask. And then deriving this, 2 goes to the front. I keep the pi. That's it. Any question for the derivative?
No.
Okay, r is like an x. That's it. Solve. Solve for r. Like as if it is an x. To solve for r, you isolate r. Okay, yeah, I like to get the minus shifted to the other side. So I get 2 pi r equals. Okay, I cross multiply. Again, there are many ways to solve. This is one of the ways. So I cross multiply. And then isolate r, and that's it. 2 pi r cube equals by 2. Okay?
Yep.
By 2 pi. So r cube would be, okay. Now you use calculator because this should be in decimal for sure. I mean, the expression would be in pi. It doesn't make sense. If someone asks you, imagine you are working company and the manager asks you, okay, what are the dimensions? You won't say this is 3 pi, 2 pi something. You want to say exactly, it's like 5 point something, okay? You want to find this in decimal. Anyhow, so I should get rid of the 3. So we say cube root. So we say r equals cube root of 2000 over 2 pi, exactly. Now go on to your calculator. If you don't have a cube root, well, you can put it to the power 1/3, okay? If someone asks you, this is to the power 1/3. Okay, but we have it somewhere, I guess. We have this, x is the 3, but for me, I want to put it to the power 1/3. So 2000 divided by, be careful, when you divide by 2 numbers, so it is open bracket. Your calculator won't understand without 2 times pi. Okay? Okay?
Yep.
So this is exactly the division. Now this is all raised to the power 1/3. Again, you have a cube root on your calculator, you put it, blah, 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 but just I'm demonstrating in a different way. This is exactly should get, so r equals, and you preserve the unit. Now, how many in decimal? You usually 2 decimal places are enough. So 6.8 to 78. 2 decimal places, just I want to demonstrate how you round up, okay? You round, okay? So 2 decimal places, I want to cut it right here. So if this is a number 5 or more, you add a 1 to this guy. So R would be 83 because, yeah, they expect you to know. They expect you to know all this stuff. So imagine it is online and you put 6.82. They say it's wrong. It should be 6.83. So be careful. Okay, it should be indicated, by the way, how many decimal places they ask. Okay, the units. What are the units you have? So that it is in, okay, you go on. This is our radius in centimeter. Any question? So I want to make it clear, rounded to 2 decimal places, because they may ask differently. It may be the whole number, it may be 3 places. Okay, just to make sure why I cut it. Okay, anyhow, what are the dimensions of your cylinder? Not yet given or determined because still h, but h easy to find because I have it right here. Okay, so be careful, it's already done. As a h is this, it's taken from the volume. So 1000 over pi r squared. So 1000 over pi r squared is my h. Okay, yeah, use calculator, how much? Squared, yeah, that's it. Do you have calculator? Go ahead. Let us see if you get the same answers. Go on. Yeah. If you get it allowed. I have the score there. Okay. You see how I put the fraction in between brackets. If I miss the bracket, it would be wrong. Okay. you would be computing different for a different answer. Okay, now it should 6.82. Yeah, it happens that this is a nice dimensions because they are almost the same.
Yeah.
Okay, it's not a surprise. It may be all of the same. 6.8235. Again, I want to demonstrate. If I want to cut it to 2 places, so I want to cut it right here. This is a number below 5. Okay, so we don't add. It doesn't add to the digit before. I want to cut it on 2 decimal places. So I'm talking about this. Yeah, right here. So this is a number below 5. I won't add to the 2. So my height would be 6.82 in centimeter. Why those are close? I mean, it happens. These are nice. In real life, those may pop. Okay, this is the reason. I mean, if you go on, you see some bottles look this way. It's like why the height is low, and some bottles look like thin and longer. Okay, you see, like there are what energy drinks that look like thin and long. You see, right? And some that I don't know bottles in the market, those are cans. Okay, cylindrical shapes. But by the way, they take into consideration when they ship these, okay, into trucks and even into tanks, blah blah blah. Okay, all those are taken into consideration. Be careful. How do they package those? What is it that to have the smallest area? You know why? Because smallest area, less cost.
Yeah.
Okay. Anyhow, this has to do with business later.
Yeah, for sure.
Okay. Any questions? So do you see optimization is a topic? It goes into engineering, but engineering is a demand of business. You I don't know, maybe in computer later on, you're in science program, but this is a problem that has to do with business. Business asks, okay, please build some object that minimize our cost. Just go on the demand. Yeah. So we are done with optimization. It's a nice topic. It's a real life application. So I gave you cylindrical application. I gave you what? This has to do with the box. It's like a cubic shape, okay? And we have done a different problem that has to do with the semicircle, or what? It was a parabola with a rectangle in. Now we get to a new skill. Okay, we're almost covering the topics after required for the final. Now there's a topic that you have to be aware about, which has to do with the absolute maximum minimum. So let me check. And we're talking about the maximum minimum, concavity, inflection. This is an introduction. It's like a skill required before we go further. Okay. So what is the question about, by the way? Absolute extrema. Now, as a background, what do I mean by extrema? The extrema, the extremities. Okay, it has to do with the maximum or minimum. So imagine, so this is the background. I mean, imagine you have this shape. This is called the max. This is called the minimum. Okay. Now, if I come on, let me extend this a little. Take this down a little. If I come on a certain interval, I'm just explaining what's going on, but that shape is not related to f. It's any. Okay. If I take a certain interval means take a restriction. If I restrict my study in between something, so I want to here to there, so it's like I cut it off. Okay. So I'm taking this shape. I'm literally taking this shape. Okay. Now, let me. So this is the maximum. You see, I want to just demonstrate. This is the minimum. Anyhow, so the extremities now. What is your maximum minimum? It's still this as a maximum because I still see this is the highest point and this is the lowest point. Do you agree? So minimum means the lowest point. Any questions so far? I'm just explaining the theory behind. Okay, the maximum is your highest point. You get it?
Yeah.
Okay, now I want to take a different example. Imagine again, I have, let's say, I have this shape. Okay, now be careful. What do you call this? Max. What do you call this? Minimum. What do you call that? Max. What do you call this? Minimum. You have many max, many minimums. Do you know what you call those in green? Those are called local extrema.
Yeah.
Local extrema. The local. Those are not absolute, huh? Be careful. What I am talking about right here, even local. But when I take an interval, so imagine I want to restrict my study from this part to that part. So I cut it right here, I cut it there. Those points, extremities, should be included as well. And I want to see if this stands for the highest or not. You see? Now you see. So this is my lowest point right here. This now stands for the lowest point. And right here now stands for the highest point. So the absolute extrema takes into consideration those inner local extremities. And you want to see which one among is the highest, which one among is the lowest. You get it? So in this example, this is my highest and this is my lowest. In that example, I cut it off, but those weren't the highest. That was the highest and that was the lowest. You get it?
Yeah.
Anyhow, so this is the background. In a brief, how do you solve it? In a brief, how do you solve it? You go this.
Okay.
So I gave you the theory behind, but how do I solve? I do 3 steps. Step 1, the extremities have to do with the derivative. Say find f prime. Okay, step 2, set f prime equals 0. You know why? Because you want to get the critical points. We say critical values. This is guarantee find the critical values. Critical values are the values where the maximum minimum occur on. So those are the local, I mean.
Okay.
Find critical values. And then what shall I do is like I want to take into consideration my interval.
Yeah.
I want to ask you, what does 0 stand for, by the way? What does 0 stands for in the 3? What letter names can you give for 0 and 3?
X and Y.
So what is 0? X equals 0, right? What is 3?
Y.
No,
Oh, no.
it's a common mistake. It's not a point. This is x1, 0, and this is x2 to be 3.
Sorry about
Uh-huh. So be careful. Interval is not a point. Not a point xy. Okay, so this is first x, second x, and it is demonstrated graphically. In like when I cut it on, it's like there's an x here and x there. Okay. So why that should be taken into consideration? You know why? Because what is step 3 is those values of your interval should be replaced in your function. That is literally what I was talking about graphically. Because this interval, I said, when I cut it left, right, this denotes the 0 and the 3. Anyhow, so what you do next is replace the values of your interval, replace, we say end points, end numbers, okay? Replace end points of your interval in your function. Replace end points of your interval. Where do you replace these?
In the function.
Replace end points of your interval, f of x. What are you finding is like fx1, this is my x1, x2, and f. This is what I am finding. And then, by the way, what do you get so far? What do you get so far? So find the critical values. So right here, I will get x values. And from here, I have x values, but I got f of those. So I am talking about the y. The absolute extreme has to do with the y, okay? How high you go, how low you go, okay? The highest, lowest. But you are talking about a point, so you are talking about x related to y. Anyhow, what is step 4 is compare all the f values, compare all y values, compare all y equal f of x values, and you pick highest lowest, okay? These are the steps to pick highest and lowest. When you pick the highest lowest, it means the absolute extrema. The absolute extrema is the absolute maximum. Highest would be called absolute maximum. Absolute minimum. What does it mean? It means no less than this and no higher than that. Absolute is the highest of the highest and the lowest of the lowest. Any question?
No.
I didn't solve even because yeah, I gave you the theory behind and I gave you the steps. What should you do? You have 4 steps. Let us solve it.
All right, let's do it.
Let's do it. So go ahead, find the derivative. Find the derivative. Now it's a quotient rule. So I wanna apply the steps now. Step 1 again. So f prime equals u prime v minus over v squared. So right away, derivative of the x is a 1 multiplied by that. So you keep it minus deriving the lower, you get 2x minus 1. So you put in the bracket multiplied by the u. Okay, all divided by x squared minus x plus 1 squared. Now this is step 1. Step 2, we said I want to put this equals to 0 over 1. So when it's a 0 over 1, you cross multiply. That would be cancelled. Bye-bye. Okay? Because it's times 0. So what I end by is the numerator. So I would end by, simplify it right away. So you get x squared minus x plus 1. So let us FOIL it. X into. And x into with a minus. Minus times minus is a plus. Okay? Any question? Equals 0. Any questions so far? How I jumped? So this is step 2.
Yeah, I just have a question with your u prime v. X squared one is
deriving the x is a 1. So I put it right away. 1 times this. That's it.
Oh yeah. Silly question.
Okay. Yeah, I put it right away.
Yeah.
Okay. Now up till here is okay. Step 2. I'm following the steps exactly. Step 1, find f prime. Okay, put it to 0, solve. Now, which ones are the critical values? Yeah, I want to solve it. Solve to get the critical values. Go ahead. Solve this. So now I want to simplify it for sure. So this would add up to, and x is cancelled. Now they gave you a nice relation, by the way. Okay, what is the nice relation? It's like easy to solve. That's it. Okay, solve it easily. What do you get? Yeah, go ahead. What are the x values you obtain?
You get x is 1 minus 1.
Yeah, so if I wanna take off the minus, I wanna push it to the right side. So equal x squared. Put radical on both. You get x equal plus minus 1.
Yeah.
So the critical values are the values obtained. Any question? The critical values are x equal 1, x equal minus 1. Okay, now step 3, what do they say? They say replace end interval. Now I jump to the interval. What is my interval given?
It is 0 and 3.
Okay, interval 0, 3. Oh, those are called endpoint, but because this is called x, x1, x2. Okay, so I want to replace those in f. So f of 0 should be determined, f of determined. Okay, so plug them in your f. What is your f? It's x over?
X squared minus x plus 1.
Over or 0 over? 0 over, how much?
X 0 minus
X
0.
squared minus x plus 1. Okay, so x squared minus x plus 1. Just to demonstrate. So this is 0. Plug in a 3, it says x over. Let me change color. So it is 3 over. Any question? 3 squared minus 3 plus 1. You agree? So it's a 3 over 9 and 10, 7. Okay? Sorry, it's a 9 plus 1, 10 minus 3, 7. 9 minus 3, 6 plus 1, 7. It's correct. Yeah, 3 over 7. Okay, that's it. So that's what I look on. That's what I look as well. I want to look at 0 and 3 over 7. Those are the y values. F0 means y. Step 4, I still have to determine f of the rest. Replace the endpoints of your interval, okay, and compare all. So I wanna get f of the critical values. I didn't find so far. So I should do the f of 1 and f of minus 1 as well. You agree?
Yeah.
Okay. Again, plug in a 1 in your function. So what do you get? If you plug in a 1, you get 1 over 1 squared minus 1 plus 1.
Yeah.
So this add up to 1. If you put in a minus 1, tell me what do you get if you put a minus 1 over squaring of this minus, you get a plus, plus. You agree?
Yes.
Okay, minus 1/3. So I want to look at this, I want to look at that. So now 0, 3/7, 1 and 1/3. Which one is the highest among as a value? Which one is the lowest, again, as a value that you pick to be the highest or the absolute maximum, minimum, and that's it. So step 4, let me make it clear. So step 4. Okay, so tell me on that side. So minus 1/3 is the lowest. I don't have a minus other than this. So this is the absolute minimum. You agree? What is the highest? Is it 1 or 3/7 or 0?
1.
So this is absolute max. You agree?
Yeah.
Okay, now how do you present your answer? Be careful because it depends how they put it in the choices. Okay, but by the way, when you did the exam, there were fill in, right? There were no choices. Okay.
It was nothing. It was just scan the sheet. Yeah, just fill in. Yeah.
Okay, so the presentation of the problem was, as you see right here. Okay, is it similar way like?
Similar, yeah. And then
Similar.
all I had to do was check that I had completed the problem, and that's it.
Okay, good. Okay. So okay, perfect. So for example, in that problem, they don't mention usually how many places, but it's not in the exam. Professors do say around to 2 decimal places. Okay, so if they don't mention, it is by default. Right here, for example, what you are supposed to do, write a statement as your answer now. So I want to. What is my absolute maximum minimum? I put a note, yeah, but how do you present your answer? I would say absolute maximum. Tell me, what is the absolute maximum as a value?
It's
The absolute maximum is the y value. What you see here is the absolute maximum, but occurs at x equal 1.
Yeah, so it's 1, yeah.
Absolute minimum as a value. The lowest value for the function is this. It's minus 1/3, but it occurs at x equal -1.
Yeah.
So I may represent this answer as I was reciting, okay, in a minute ago, but I may present it as absolute maximum occurs at a point x1, y1, x -1, y -1/3. You may present it this way or the other way.
Yeah.
Which way you prefer, it's up to you.
Yeah.
Which one? Do you want to write the statement or just write it occurs at this?
Just occurring at the point.
Okay, so I would say absolute maximum occurs at point. So how much is x? Y. Absolute minimum occurs at how much is x? How much is y? But for understanding, I want to say this. Absolute maximum is how much? Is absolute maximum is the y value always. So absolute maximum is 1 at x equals 1. You get it? It happens to be both the same. Okay, absolute minimum. Tell me, how do you, I am presenting it the other way just for understanding. How much now? Absolute minimum is the y value. It's -1/3 at x equals how much?
-1.
That's it. It's a perfect answer. Okay, do one more as before. Go ahead. Yeah, same question. Okay, find the absolute extrema of. Go on. So right away, I would say f prime equals 0. Okay, find the derivative. Now this is x into e to the minus. So there's a product in between. Okay, we agree. So just for the sake of demonstration, I would say it's u prime v plus v prime u equals 0. You agree? Okay, let us derive straight. Deriving the x is a 1 times v plus deriving the e is itself, but I'm not done yet because the top, which is -2x, times the u, how much is my u? Is x. Any question? Okay, so if I want to just make it perfect for explanation. I want to say I'm following u prime v plus v prime. So all this is v prime. U. Okay. What is my u? Is x. Okay, you're silent. Why? Okay, v prime. This is my v prime. Any question on the derivative of the e?
No.
Okay, perfect. Now, I want to solve it. Now, solving exponentials are not easy. What do you do if you see common? So I want to ask you, how many terms do you have? Let me write this properly. If I want to write this properly, this is a term, or in simple form. And that is another term in a simple form. What is that term, by the way? What is that term?
That's your
It's x times x, so and there's a minus. So minus 2x squared e power. So this is, yeah, I see many students are confused. A term is a quantity by itself. A term is a quantity. Any separation between signs is a term. So when I say, for example, xy plus 3x squared y minus 5x radical y x, for example, how many terms do I have? Three, yeah. So this is a term. That is another term. This is all a term. This is another term, and so on. Okay. Because if you are not aware of these terms, you won't be able to take factor among terms, okay? Because what comes next is taking a factor among terms. So this is a term that is on. A factor is a repetition between. So I see e power is repeated. There's a one hidden. So take e power minus x squared. This is the way you solve it. Now, if you take e power minus x squared as a factor, what is left should be written. So this is taken, I see a 1 beside. So 1 minus. If this is taken, I see 2x squared beside. Do you agree? So this is what should you write next? Any question? Factoring is a must in order to solve. Now, when factors equal 0 or more, so each factor should be 0. You agree? I want to set this to 0, and I want to set that to 0. So e power minus x squared equals 0 has no solution, because if you apply ln, you won't get a solution. You agree? Always from e power something, you don't get any solution. So e power minus x squared, it means no solution. I don't get an x from that. I get an x from this factor. If I want to solve it, I would get 1 minus 2x squared equals 0. Isolate. I would get 1 equal. Isolate, divide by 2, and then put a radical. How many answers do I get?
You get plus minus.
Plus minus how much? You put a radical, simply radical half, and as 1 over radical. Simply keep it. Okay, plus minus. That's it. So what are we doing, by the way? Well, yeah, it's much harder than the one before, because it's deriving not quotient rule, and there's e involved. But we are doing the same steps, but it's longer. Anyhow, these are the critical values. Are critical values. You agree? Okay, what comes next is I want to replace this in f, and I want to replace those of the interval as well. So the next step would be replace all values of x. I'm rewriting it, paraphrasing in a different way. Replace all values of x in f, okay, to obtain or to decide on the absolute maximum minimum, to decide on the absolute extrema. You agree? Do you agree?
Yeah, yeah.
Absolute extrema. Way of, I mean, understanding. If you wanna, let's say, explain to someone in your class or to a classmate, okay, this is what you should say. I want to replace all values of x in f to decide what are those all values, the critical values and the values of your interval, because those stand for x. This is x1 and that is x2. Not critical, those are the endpoints of your interval. X equal minus half, x equal 1. So how many x values do I get? I get f of minus half, f of half. Those are for the critical. It happens sometimes that the critical are among the intervals. So my interval is minus half 1. So I half, I want to get the rest. You agree? Are you confused? Is it okay so far? I mean, minus half occurs or pops in two forms. By the way, it's minus 1 over radical 2. Okay. But in case you have minus half, yeah, this is something else. In case minus half is critical and in the interval, you write it once. Yeah, but those are all different anyhow. I have radical 2. So I didn't notice. I want to fix this to be radical 2, and then, you know, I have minus half and the 1. So to just for sake of explanation, those are from the interval. From the interval. Okay, and those are from the critical. You agree? Any question? Okay, do you have a calculator? Oh, by the way, it's tough because your function is x e power minus x squared. You want to get this in decimal for sure. So let me pull my calculator and do it in parallel. Go ahead. So can you figure out the answer? You have calculator or no?
Yeah, I'm doing it right now.
Yeah, go ahead. So put minus 1 over square root of 2. Yeah, if you get an answer, say it. E, where's my E? E associated with the long, so this is E to the power. Be careful how you write this. Squaring the minus 1 over radical 2. Okay. Is your answer matches mine or not?
We were doing the different ones. I was doing the 1/2. You're doing the
okay,
round.
so you see, I mean, you can literally check, I mean, the way I plug it in. So this is x minus 1 over radical 2, and then e to the power minus, okay, I put the minus aside from the square, and that's it. Anyhow, you should get the same answer. Now, it should be rounded to places, so minus 0.43. You get it? Okay, now, if you plug in a plus, I mean, this would be, if you plug in a plus for this guy, okay, so that would be a plus 1 over radical 2, e to the power minus, so the minus stays, I mean, you will get this, okay, it was the same answer, but this is a plus. Okay, that you can check, okay? Now I want to put a minus half, I want to change this to a half now. I want to remove the radical, so minus half only. I want to remove the radical. Good? Okay, I got my 0.39.
Yeah, that's the half. Yeah.
Okay, for the one easy to determine, it's e to the power minus 1. Well, let me just plug it on, e to the power minus 1. And it would be 0.37. You agree?
Yeah.
Okay, that's it. So this is what literally we did in the previous problem, but I mean, with the have more calculations. Anyhow, so what you do now is you look at the highest value. So I see this is 0.43 is the highest. So this is my absolute max. And the lowest of the lowest, I have minus, but this is the lowest. So my 0.43 is my minimum. You agree?
Yeah.
And that's it. But you wanna make it clear. I prefer write it as a statement, not to put a point, because just I was demonstrating if they play with the way the answer is presented, because your scenario is not like fill in, so there's no worry about. I prefer to present it this way. This is the best way professors like. Is this at, okay, but that may be in another online exam to put it as a point. Okay, so finally I want to write it properly. I would say so write a statement. Go ahead. What shall I write?
Absolute max occurs at 0.43 at x equals 1 over square root.
Yeah, good. Is this value at x equals 1 over radical 2. Absolute minimum is minus 0.3. I mean, this is by chance that those are the same. It's not like a rule, okay?
I was gonna ask, is it like pretty much always going to be associated with the critical points?
No. There's no rule for that. There's no rule for.
It so happens that it's
No,
this
it
one.
happens by chance.
That's why you have to compare all four, because
Yeah,
sometimes.
because if you go to the theory, no, it is. If you go to the theory, I gave you the background. Okay, right here. So it depends on the graph, and it depends where do I cut. For example, if I cut it there, if I cut it right here, no more. This is the absolute height or absolute maximum. You see? Now this is the maximum. Where I cut respective to the function, it matters. That's it. I mean, so there's no theory. Which one pops as a absolute maximum minimum? We don't know. For that reason, we do all these steps. That's it. Okay, perfect. So we did today optimization, and we did discovery related to absolute. We continue
Next week.
Yeah. Okay.
All right.
Any questions so far? So good.